All right, so Unit 7 review. So this is review on probability. Number 1, data for the students enrolled in a local high school are shown in the Venn diagram below. If a student from the high school is selected at random, what is the probability that the student is a sophomore given that the student is enrolled in Algebra 2? All right, now we know when we see given in a question, we kind of start right there. So given that the student is enrolled in Algebra 2. Okay, so this is our given category. Everyone within this circle is in Algebra 2. So altogether there are 210 plus 85 people that are in Algebra 2. So that means we have, I'll put it up here, 295 people in Algebra 2. Okay, so that's going to be the denominator of our fraction. Now, out of those 295 people, now we look before the word given. Okay, so now we look at sophomores. So how many people within this circle are sophomores? 85. Okay, these 85 people right here are the sophomores. So 85 over 295. Choice 2. Okay, number 2. Juan and Felipe practice at the driving range before playing golf. The number of wins and corresponding practice times for each player are shown in the table below. Now, what I'm noticing is they don't total everything out for us. So that's the first thing I'm going to do. Okay, I'm going to add up how many total times Juan wins. So 8 plus 15 would be 23. And then I'll add up how many total times Felipe wins. So 10 plus 12 is 22. All right, and then, I mean, if I want, I can add these two to total out over here. So 23 plus 22 would be 45. That means there's 45 total games. And then if I add my way across, short practice, well, 8 plus 10 is 18. And long practice, 15 plus 22 is 27. And just to double check myself, if I add up these two numbers, they add up to 45, so it all checks out. Okay, so there's two parts to this question. The first part, given that the practice time was long. So again, we see the word given, so we're starting here. Given that the practice time was long. So this right here is our given category, okay? We're only going to use numbers within this box, okay? So these are the only numbers we're allowed to use, nothing outside of that. All right, so given that the practice time was long, so if we go to the total of that category, it's 27, so that'll be the denominator of our fraction. Okay, now let's keep reading. Determine the exact probability, which just means leave it as a fraction, that Felipe wins the next match. So out of the 27 long practice times, come over here and say, look, 12 out of those, Felipe wins. So 12 out of 27. All right, and then the next part, determine whether or not the two events, Felipe wins and long practice time, are independent. Okay, so I know there's other formulas for independence, right? But this is the one that I find a lot of people use a lot. So I'm going to start with this one, and then I'll show the other formula. Okay, so I used F for Felipe wins and L for long practice time. Okay, so the first part of this formula wants us to find the probability that Felipe wins and there's a long practice. So here's Felipe wins, here's long practice. If we look at where they intersect, that happens 12 times. Now 12 times out of the total, 45 times. So 12 out of 45. And make sure, when you see probability, we need to make sure we put it over the total. All right, now, the reason I put a question mark here is because we don't know if they're going to equal out or not, so we'll see. All right, let me bring this down. Now, the probability that Felipe wins. Well, Felipe wins a total of 22 times out of the 45 games altogether. So 22 out of 45. Okay, and then the probability of the practice being long, well, altogether there are 27 long practices out of the 45. Okay, so I use my calculator here. So I made sure to plug in the left side of the equation into the calculator because I wanted it to simplify for me. So on the left side, we have 4/15. Okay, now I see here I'm going to put does not equal. Okay, these are not equal to each other because when I type in the right side of the equation, that simplifies to 22 over 75. Okay, so those are not equal. Okay, so that being said, since these don't equal to each other, it means the events are not independent. And don't forget to write this out. This is the actual answer. This is just the work. When they say justify your answer, this is my justification, but this is the actual answer. Now, I also did want to show, let me do it in a different color over here, the other formula we could have used, and especially because in part A, it says given the practice time was long, right? They wanted you to determine the probability that Felipe wins. So the other formula we could have used is the probability that Felipe wins given the practice time is long. Now, if that is equal to, think about the formula for independence. The formula for independence says the probability of F given L equals the probability of F. So if this is true, then we can say they're independent. Now, we already found this, right? The probability that Felipe wins given long practice time, that we already found up here in part A. But if you wanted to look at it again, the probability of Felipe winning given long practice time, so if we're given the long practice time, that happened a total of 27 times. And out of those 27 times, the probability of Felipe wins would be 12. So 12 out of 27. And then over here, the probability that Felipe wins, well, Felipe wins 22 times out of the total 45 games. So 22 out of 45. Okay, so we could see I plugged in the left side of the equation, which simplifies to 4/9. And the right side of the equation is already in simplest form. So 4/9 does not equal 22 over 45. So again, if you use this formula, you'll still see the events are not independent. So you have to write that out. So you could choose whichever way you want to do it. Okay, number 3. A student is chosen at random from the student body of a given high school. The probability that the student selects math as the favorite subject is 1/4. So I'm just going to organize my information because I could see through this problem we have a lot going on. So the problem of math is 1/4. Okay. The probability that the student chosen is a junior is 1/16 over 459. So the probability of being a junior is 1/16 over 459. Okay. If the probability that the student selected is a junior or that the student chooses math as a favorite subject is 47 over 108. Okay, I'm going to stop there. They give us the or, so let me write that down. So the probability of it says junior, remember this is a symbol for or you can write the word or, math equals this. Okay, let me just keep reading. What is the exact probability, so just leave it as a fraction, that the student selected is a junior whose favorite subject is math? So we're looking for junior and math. All right, so we're looking for the probability of junior and math. Okay, we don't know that, so put a question mark. All right, now you could do this one of two ways. You can either do a Venn diagram or you could use the formula. I mean, whichever you think is easier. So let me start with the Venn diagram, and if you don't like that, then we can use the formula. Okay, so in our Venn diagram, here's our math circle, which we know is 1/4 on top. And then here is our junior circle, which we know is 1/16 over 459. Now this is in probability form, not whole number, not total form. Now the or, here's how the or works. We know that with the or is the sum of these three circles. So let me do it like this. The sum of these three circles should add up to, right here, 47 over 108. Okay, now we don't know any of the numbers within the circles, but let's think about it. If we were to add up the two numbers on top of the circle, it should add up to more than this, because isn't the sum of these two numbers, that's how we get the 1/4, and isn't the sum of these two numbers how we get the 1/16 over 459? So if we added these together, whatever's here would be accounted for twice. It would be accounted for within the 1/4 as well as the 1/16 over 459. So if we add these together, it should add up to more than this, because whatever's here was accounted for twice. So what we want to do is we want to add these two numbers together, right? These two numbers right here, add them together. And to figure out what was accounted for twice, subtract this from it. And however, whatever the difference is, that's going to be the number that goes here. That's going to be the number that was accounted for twice. So I added these two up and got 923 over 1836. And then I subtracted the or from it. And that told me that 31 out of 459 was the number that goes in the middle of the circle. That was the number that was accounted for twice. Okay, so all I did was just copy this work onto my paper, but the probability of math and junior, or actually I wrote it the opposite here, same thing, junior and math, being a junior whose favorite subject is math, is 31 over 459. Now, if that was tricky for you, you could also just use the formula. So let me go over that too. Okay, so we're just using our addition formula, which we use when we have or. And really, you're just going to take all these numbers from over here and just plug them in. So they give us this. They give us this. They give us this. And we want to find the and. So I'm just going to call that x. Okay, so to solve this, you would first add these together, just like we did in the Venn diagram, right? And when we did that, what did we get? It was 923 over 1836. We'll bring everything else down. We're trying to solve for x. So let me now subtract this fraction from both sides of the equation. And these numbers might look familiar because it's the same numbers we had when we were doing the Venn diagram. Okay, so these cancel, leaving me with negative x. And when I subtract these, you can do it in your calculator however you want. You wind up actually getting negative 31 over 459. So if negative x equals negative 31 over 459, just divide by negative 1. Positive x would equal, do it over here, would equal 31 over 459. So either way, we get the same answer. Okay, but we're not done with this question. The next part says, this is a longer question. Are the events, the student is a junior, and the student's favorite subject is math, independent of each other? Okay, I'm going to erase a little bit to give myself some room here, but you could try to squeeze it on your paper. Okay, so here I wrote down our independent formula, and I'm just going to fill in the numbers. So the probability of J and M, look, isn't that what we just found? So 31 over 459. We want to know, is that equal to, that's why I have a question mark on top of this, the probability of J, which we know is 116 over 459, times the probability of M, which we know is 1/4. Okay, so let's see. Okay, so we could see that the left side of the equation does not simplify. That already is simplified. So I'm going to take that and bring that down. And I'm going to put a slash to this equal sign, because look at that. When we multiply these two fractions on the right-hand side of the equation, we get 29 over 459, not 31 over 459. So let me just see the way this is worded. Are the events independent of each other? So no, the events are not independent of each other. All right, so there we have it. All right, let's see what we have next. Okay, number 4. A fast food restaurant analyzes data to better serve its customers. After its analysis, it discovers that the events D, that a customer uses the drive-thru, and F, that a customer orders French fries, are independent. The following data are given in a report. Okay. All right, so these are our two independent formulas. We have our first one right here, and we have our second one right here. Now, by looking at what they want us to find, it says, given this information, the probability of F given D. Well, if that's what they want us to find, I'm guessing we're going to use this second formula right here. So we know that the probability of F given D is equal to the probability of F. So look at that. The probability of F is 0.8. So there's our answer. All right, that one was kind of just straight to the point if you knew the formula. All right, and then it looks like there's one more down here that we probably need to know formulas for. All right, so consider the probability statements regarding events A and B below. All right, so they give us all this information. They want to know, what is the probability of B? Okay, so this has a lot going on, so I figured we might as well pull up the formulas so we could see what we're given. Okay, first of all, they give us the OR. So here's our OR formula. Do we have enough to use this formula? If we want to use this formula, we would need to know the probability of A, which we don't know. We're looking for the probability of B, so we don't know that either. We do know the AND, but because there's two unknowns, we're not going to be able to solve that for the probability of B. So this formula, we're not going to be able to use. Now, if they don't mention the word independent anywhere, which I don't see, it means we can't use our independent formulas. You can only use them if we see the word independent. Okay, so far, we know we're not using those formulas, any of these formulas on the bottom, because not enough information, and we don't see independent. So it looks like we're probably going to be using this formula. So let's see. The probability of A given B. Well, that's what this means. This symbol means given. The probability of A given B. Okay, so we know that. The probability of A and B. Oh, we know that. And then down here we have the probability of B, which is what they want us to find. Okay, so this is the formula that we're using. Okay, so let's plug in the number. So the probability of A given B, they give us, is 0.8. Let's plug in a 0.8 underneath that. Okay, then equals, and now we have a fraction over here. The probability of A and B is 0.2. And since this is what we're solving for, I'm just going to call it x. Okay, so let me put this left-hand side of the equation over 1, and I'm going to cross multiply to solve. So 0.8 times x is 0.8x. 0.2 times 1 is 0.2. And to get this x by itself, I need to get rid of the 0.8 in front of it. So since it's 0.8 times x, the opposite of multiplication is division. So let's divide both sides by 0.08. Okay, and then 2 divided by 8 is 1/4. So wouldn't 0.2 divided by 0.8 be 1/4? Or look, it looks like they put it in decimal form. 1/4 is equal to 0.25. And I mean, even if you plugged this in your calculator, it would give you 0.25. So choice 2, even though I covered up choice 3 and 4, I can't even see them, choice 2 is the answer.